All right, let's see. Make sure the levels are good here. Cool. That seems like it's all good. Kill the audio on that, and we'll head over to the desktop. All right, so we're gonna pick up where we left off yesterday, which was on the transfer encoding content length example. So yesterday we did the content length transfer encoding, which is when the front end respects the content length and the back end respects the transfer encoding. And we started working on this transfer encoding content length where the front end respects the transfer encoding, but the back end respects the content length. We didn't get that working, so we're right here. I'm gonna go ahead and open this up. I'm also gonna open up burp, and let's get a temporary project set up. It might make sense for us to actually like make one. I don't know, but I'm gonna go ahead and add in scope for us. This is gonna build us a thing. So this is our address. We're gonna copy that, and okay. So basically, what I'm doing here is just making it so that burp doesn't bother capturing data from any hosts that aren't the one that we're working on. I really just don't care about that data, and I don't want it to like just take up a bunch of space in here and kind of like distract us. So we're all good there. We should be able to open up the browser, and we can just get rid of that. If I go to here, our history should populate. We're gonna have some data in here. And like we expected, we only have stuff from this host. All right, so yesterday we were working on repeater, and we basically got some requests built in here. What I'm gonna do is head back to here, and I'm going to send to repeater. And I'm going to get rid of basically all of the crap here that we don't really care about. And we need to do a couple things. First is we need to add a content length header. I don't know what the length is going to be yet, and we're going to have to add a transfer coding chunks. This is basically just like the default stuff we're going to need. We know we need to have a chunk request, and we know that we need to have content length. Our body is going to look something like this. So our chunk is going to have, see, I think we're going to want to have, we're going to need to have 3 bytes probably, just because we're going to have to be able to get the whole thing read. And so G, and then our 2 like invisibles, so like our carriage turning line, and then 0. And if we look at this, I also need to turn off that. So our content length is going to be 1, 2, 3, 4, 5, 6. Actually, no, we don't want it to be that. We want it to be 1, 2, 3, 4. Because that's going to stop right after the G, and we want it to stop reading, even though there's like extra crap there. So I'm going to go ahead and send this, and it's back to where we were before, the invalid request. We don't really have much visibility into why this is happening. Presumably it's because we're sending a bad verb. So I'm going to go ahead and just open a new one of these. We're just gonna like make this super easy. Oh, you know what I forgot to do? I forgot to make this a post, because it's gonna want to have a body there. Yep, all right, so still same thing. We're gonna try gget, and we gotta put the stuff in here. Three. And it's just waiting. That's interesting. Like, let's cancel this. Yeah, so we had this problem yesterday, and I don't remember what happened, like why it happened. Where the requests just didn't work. Like, this is set up all correctly. It is the correct host. That's correct. And it's almost waiting. I mean, I guess we could do this the easy way. Like, I truthfully don't know why that's not working, but we can go to proxy and just send a repeater, and we'll get one that works. But, oh, you know what? Because it has HTTPS in here. It has the... No, that does too. Do I need... Okay. That's, it didn't have the empty. That's the magic. Okay. So presumably, like, we can see if this is what it took to get us that response. Only methods get, post are allowed. So that's what we would be seeing if, you know, what was here was wrong, but we're getting this invalid request. We don't know why it's giving us an invalid request. We don't really know what the request looks like, which kind of sucks. I mean, that would make it a lot easier for us. I wonder if we can do this. Yeah, so it doesn't change. It's still 4. And like, I don't know that it matters like which order we put these in. Like it probably shouldn't. Yeah, it doesn't. Yeah, but like, that's the part that kind of is shitty about this. We can go back to here and we can try using the tool again. Maybe it just makes sense to like spend time working with that. So we launch the probe. The probe is going to go and do its thing. And it should pop up a thing up here when it like figures out that like, oh yeah, I can actually do, it can actually like find it, and then it gives us like something from it. Yep, cancel that. So now the front is going to do this. And so what we want Okay, I wonder if our problem is that it's putting the 3 instead of the G. Like, so what's here, or sorry, what's here is going to be hex encoded. We could try putting G there. We tried this yesterday, and I don't think it worked, but maybe our offsets were wrong or something. We can look up our ASCII table for capital G, and it's hex 71. And so it's gonna treat that as the number hex, whatever hex 71 is. I'm gonna do this on screen so that everyone can see. Does it terminal? Yeah. Let's spin up the Linux host on here. Okay. Hex 71 is capital G. That's 113. So we need 113 bytes minus 2. So we're going to go 111. We'll see if this actually copies. I don't know if this is garbage or not. All right, so that worked. So this should be that many. Still invalid request. But now we have what is a G here. Oh, and our content length is wrong though. V1. Yeah, so still invalid request. So what ends up happening is this comes in through the first layer, which is transfer encoding chunked, and it's going to read all this in. This 71 is 113, which is 113 bytes right here. Interesting. It's 174. What is this 107? Oh, that must be like the timing or something from the request. So this is 111 bytes, 112, 113. 71 is 113. So this gives us a valid chunk that it can read. And then when it gets all the way through the content length, and maybe this is the problem, is that when it gets to the content length part, this isn't treated as the hex value 71. It's treated as the the string 71, and that's probably the issue. Let's see what it found here. So if we go back to dashboard, it says it found some stuff. Delayed response. So it found all these things. We want value prefix, I would assume. So I wonder if we can do... Yeah, and this is gonna fail. It's the same thing we were seeing. What's interesting though is that I don't quite understand how this works. So we have this X here. And so it's going to replace the 0 here with the chunk size and the okay, so I think yeah, these are just not working. I wish I knew Python a little better, just because it would, I think, make this easier to do. But, so it's still going. I'm going to kill this. I think we can figure this out, though, in Python, because I think it's... All right. I don't know. We'll copy this. Yeah, just copy that whole thing. Paste anyway. Oh. All right. And then we should be able to do S replace, we're just gonna do prefix equals G. Prefix strip. Place is not defined. Oh, because that. So what differs here? It looks like nothing really differed. Which, like, probably isn't good. It means it's not working. Okay. And it didn't update it. Yeah, that's so weird. So we're not getting it updated. We know our chunk size is right. We can try running attack. So attack equals S. And it didn't update anything. Like it should be updating our chunk size, which it's not. And it should be adding our prefix, which it's not. Did we fuck something else up? Oh, you know what? It looks like it's not copying over the carriage returns. Let's get rid of those right now. Okay, so that worked. All right. And then, oh, fuck off, Python. Okay. And then so our content length becomes 4, and our chunk is 1 with a G, and then a 0. I don't know why it still has the X, but I wonder if we got rid of that, if it would fix it. Okay. That's interesting. Did we solve it? So we didn't solve it, but we do have a point here where we're getting this unrecognized method, 0 post. Which means that it is working, but this is being treated as the byte. And we're not ever going to be able to put a G here, like the letter G, because G isn't valid hex. Huh. I wonder if we can... I was thinking we'd just put a whole new request in there, but I don't know if that's going to matter at this point. Yeah, it's like a 1C here. I wonder if you see like multiple chunks, basically. Because I don't know how we'll ever make it so that like this is valid. That's interesting. Post. One G0. This is what we were using before. One G0 with 4. And so, like, if we do this, this is turned off, right? Yeah, let's turn that off. If we do this, our next request, I wonder if we just need to get rid of the invisibles here. Like this fails, and I don't understand why this fails, but it succeeds over here. Like if we look, here, this is the one before it. It looks like we have the invisibles. I wonder, oh, maybe we don't have the, okay, so yeah, we can replicate this. We're doing it, okay. But it's using 0 post because oh. What if we hex 71 and then we put, you know, our A's there. Or G's, whatever. G's 0. Okay, so we're controlling this now. I wonder if we just do 0 here, then. Hold up. This mattered. So it's 4. So it'd be like 1, 2, 3, 4. And that's the end. 4, 5, 6, 7, 9, 10, 11. Wait, did that work? So that didn't work. Whatever, so the front end is gonna read all of this, and it's gonna handle it properly. The back end is going to read the first 4 bytes, which are 1, 2, 3, 4. Which, can I make a copy of this? Peter, yeah, okay. Like, can we just do 0? Like, just do 0. It'll be 1, 2, 3, 4, 5. That's valid. Six. So 1, 2, 3. Oh, but yeah, so it thinks it's the end of the request, which is a problem because it's a 0 length chunk. And it is like 0, all right. Okay. Yeah, so I think this is failing on the first server on the front end because we're never getting the end there. Okay. We're there. So that's it. Can we cut it off? Interesting. Okay, so I wonder if no, it doesn't work. We're close. We're really close. So we're at a point where we can get the G here, but we still have this 0. We can't have a 0 here because it will end the request too early. If I bring this up, what happens? So it's 1 byte. Does that make this, like, what is, what's, character return? Is it board? Or, how do you do this in fuck, I must have just in Ruby where I know how to do it. So that's 92. So it's reading 1 byte, and then the next one is 92. And so it thinks that there's 92 bytes. So the 0 needs to be there. So that's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Seven, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It says it would be 12 then. What are we missing? We're getting it to be like that's a 0, so it's, you know, G0 post. I guess why is it reading the 0 if I specify 1 for the content length. Also go turn the air on. It's a little hot in here. Hopefully that won't be too loud. So let's get back to this. So we're at the point where we can get the G0 post. I don't know why the 0's technically there. Because, so the front end is going to send, oh, that might not be the front end. It might not be the back end. It might be the front end that is not recognizing it. I don't know which one. So and what's kind of interesting is that it doesn't have the carriage return new line here. Just has this, and so I'm not sure like where these are going. It seems kind of weird to me. Like, do we not need them? Maybe. Definitely needed. If we run this, I mean, this is what we were saying before, where the next one is 0 post. Yeah. All right, I'm at the point where I think it might make sense to look and see what the solution is for this. I don't know that we're making enough progress on here. I'm kind of curious. So they're doing a 4 content length, so 1, 2, 3, 4. So why? So they did do a 4 request there. So where am I? Just remember. There it is. Let's turn that off for a minute. maybe we don't even need that. We can see what happens if we don't use it. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Five, and it's gonna have 2 more, 35, 36, 37. What was the thing that they did that makes it magically work? Why does this work? So content length is 15. It doesn't seem like it matters. I can try adding the content type in. Oh, I wonder if it's the fact that because like it's 1, 2, 3, 4. Like, maybe we just make the content length bigger? All right. It's like application x www form URL encoded. First of all, I guess, does this work? Oops, that's not what I wanted. One sec. There is space after that. I think it's 2 lines, basically. No, it's 1. Because that gives you the yeah, so that's correct. Content type, content length. Like, this is straight up copied. So this is supposed to work. Interesting. So, but, so that worked. Why did this work? All right. So, we're putting in a full request. I don't know why the content like this is 15 here. Like, does one work? Does two? Like, I don't. So 10 is where it starts to work. Presumably it's such 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so yeah, if we turn the invisibles on here. So it's yeah, so 3, 4, 5, 6, 7, 8, 9, 10. And that reads the whole thing here, which makes sense. If it's 11, it just reads past the end into the next request that the user has. That makes sense. And so what they're doing is putting the full request in there. The content length is 4, which covers the the 4 right here, 1, 2, and then the 2 invisibles. Now, so I could effectively get rid of that trap 2, and like presumably that works. It doesn't. Is it just because it expects it to be form encoded? Unrecognized. So if we change this to JSON, can this be 9? Does that? That's so weird. I wonder if it's the application or if it's something else. But we know that works. Now if, I don't know, say I were to do this. That's not valid form encoded data, but like, so that works. But this doesn't work. That is so fucking weird. It's bizarre. Like I don't get, so I can do this and that's fine. So it doesn't have to be equal. Like I can do that. Also works fine. But oh, because this is wrong now. So CBA9 minus 3 is 7. So this should work. Turn this back on. Let me get I don't think it's gonna copy the carriage turns, unfortunately. Yeah, it didn't copy the carriage turns. It's 88, 89, 90, 91, 92, 93, 94, 95. So five. What? Oh, so it's that. So it's 85, 86, 87, 88, 89, 90. A. Now, why does that not work? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Go back to our known working. All right, so that worked. We're good. This is functional. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. but you can go forward, and this should work. Yeah. Let's hit this real quick. So what magic is it? It's just request smuggling. It's I don't know. I don't know if you're asking about that or something else, Dade, but basically we're like injecting HTTP requests into like the pipeline so that like the next request that gets serviced is the one that we're injecting. Me either until yesterday. This is the first time I've played with it. It's been on my list for like I don't know, a couple of years now to like play around. Like I said yesterday, this and deserialization attacks and Java and PHP, Ruby, Python have been on there. Those are like the two. I think like the two biggest things in terms of like web exploitation that I've been like really interested in playing more with. Like I've got a pretty strong background in web and have like done a lot with it, but I feel like a lot of the newer stuff is kind of, you know, these are like new and interesting, not new, but they're newer attacks that are like a lot of shit is popping out from them. People are getting bug bounties, so it seems like there is a lot of untapped opportunity for this these types of attacks. All right, so that makes more sense. Our problems before were that we were not doing a full request, which was a direction that I looked at and like was hoping we didn't have to after the first one where we didn't. But that makes sense, and it makes sense why we were getting the G0 post rather than the G post we wanted. The content length for here makes sense. The content length here makes sense because it's this. And yeah, we can just put our request in here. So that's cool. I think there's one more lab in this like little tutorial thing about request smuggling. We can try that. And we can do the last lab, and then I think there's more labs that are not part of this article but are just available. I didn't realize that Portswigger had like all these different things. Maybe I'll just go through and do these at some point. We can stream them or something else. I don't know. Gotta solve 46 more to become an apprentice. All right, so we did the TECE. Now we're gonna do TETE. So both the front end and the back end are transfer encoding chunked. The front end and back end server both support transfer encoding header, but one of the servers can be induced not to process it by obfuscating the header in some way. There are potentially endless ways to obfuscate the transfer encoding header. For example, transfer encoding X chunked spaces in between, like after the header name, tabs. So there's different white space. So, wow, that's interesting. Having to do with how it deals with canonicalization of the headers. I would assume that you can change like the casing of some of the header probably as well. It just comes down to like what the server is going to support. So each of these techniques involves a subtle departure from the specification. Real-world code that implements a protocol specification rarely adheres to it with absolute precision. 100% true to that. To uncover a TETE vulnerability, it's necessary to find some variation of the transfer encoding header such that only one of the front end or back end servers processes it while the other server ignores it. Depending on whether it is the front end or back end server that can be induced not to process the obfuscated transfer encoding header, the remainder of the attack will take the same form as for the CETE or TEC. CLTE or TECL. Yeah, and so these are the other blog posts I think that have more labs on them. Yeah, so I don't know if I'll have time to go through these depending on how fast I figure this out. But I don't know. We'll see. Let's try to solve this. Let's also make sure that I don't stream any copyrighted music and get my AirPods connected. There we go. All right, so we have this lab. Once this launches, we're gonna get the URL. I'm gonna get rid of this. You know what? I'm actually interested. Let's see if we can do this really quick. I don't want to play with this right now. I don't want to play with it because I don't know if this is going to deal with all like the carriage to new line stuff. I do want to get to the point where I actually know how this thing works and I'm comfortable with it. The tool seems interesting. I feel like this is easier to do right now for our just like getting the stuff going. I'm gonna add a new target in here. We're good to go there. All right. So that's good. Open the browser just to get this in here real quick. 'Cause I am lazy. All right. This is our new one. Send it to repeater. All right. We don't care about any of this bullshit here. Let's make sure this sends and still works. It does. We're good there. I am kind of curious if this will figure out, if we do the probe, like if it will figure out which transfer encodings, like tricks we can use. I also wish there was feedback here to like tell you like how long this is taking or like how much of like the assessment it's done, rather than just kind of like disappearing and like be like, oh yeah, we're all good to go here. Like I'll let you know when I find something. So it found possible request smuggling doing TECL. The fuck is identity? So yeah, it's using this. What the fuck transfer encoding identity means? indicates the identity function, no compression, nor modification. This token, except if explicitly specified, is always deemed acceptable. What the fuck does that mean? Alright, you are getting banned as soon as I can figure out how to do that. That's not what I wanted. Sorry about that, everyone. Alright. So I don't know what the fuck identity is, but apparently that works. Burp issued a request and got a response. Burp then issued the same request but with a shorter content length and got a timeout. This suggests the front-end system is using the content length header and the back-end system is using transfer encoding chunk header. You should be able to manually verify this using repeater, provide the unchecked top menu. As such, you can be vulnerable to using attacks. Alright. Alright, so what is the thing that we're trying to do here? This lab involves a front-end and a back-end server. The two servers handle duplicate HTTP request headers in different ways. The front-end server rejects requests that aren't using get or post method. To solve this, lab smuggle a request to the back-end server so that the next request processed by the back-end server appears to use the gpost. Alright. So basically we need to figure out how to convince the front end to pass it through. I kind of want to go this direction because this direction is easier for us to do. And it looks like it's done the hard work for us. Basically, I might be able to just toss this to repeater. And what was it before? And so, hold up. So this is an interesting thing. If we look at this. Okay, so that failed. We know that doesn't work. How are these different? it looks like it's just the content length. Which might mean that it's indexing at different points into it. Was it 8? Back to here. It was... This one failed. This one succeeded. 5. That's interesting. Oops. Definitely don't need that. So it's interesting, this isn't working now, but it worked before. And we're able to get this internal server error. And I wonder if it's just the state that this was in, where it had to send this one and then this one. I guess we could just send this to repeater and try this. Like, this is the same exact request. And it's just failing. Come on. All right, there we go. So we can try setting this to repeater and then do the other one. Repeater. Yeah, I'm not getting the invalid server though, which is weird. Okay. No, oh, it did. It's timing out, I guess. So if I run this and let it sit the whole time. So is it that it's the backend server is failing and so it's getting a 500 there? Let's go back to the documentation here. We can get rid of some of this stuff. We don't need it. I just don't understand like why it needs both of these, and I don't understand like exactly what the identity one does. Indicates the identity function. This token, except if explicitly specified, is always deemed acceptable. Come on. Here. Okay. It doesn't seem like it's defined here. But what the... How do you say it indicates the identity function, which is always acceptable? Does that mean that... This is chunked. That doesn't help us. Okay. So 12 years ago, this was removed. Oh, great. It's not working. Remove reference to non-existent section. These are all gone. Great. A value that only contains identity implies that no content codings were supported. This information is specific to the associated request. Oh, I don't want explicit. I want transfer encoding, not accept encoding. I wonder if it's choosing to use identity there because it doesn't actually have a meaning for one of the servers. So, well, but then why would it be I guess it's depending on if it's last in wins. So if it set this and then I replaced it with this. All right. How many bytes is this? Yeah, why is there not like a thing that just tells me like how many bytes this is? Selection. All right. Well, fine. Uh, 86, 87, 88, 89, 90, 91. So it'll be 91. It's 5B. We're gonna have to increase it for this, which is fine. And it'll be like 1, 2, 3. Seven, 8. One sec. What was the solution? It was 5C. One, two, three, 4, 5. So we got to figure out exactly like what's gonna happen here. Can I pop this out? Burp issued a request and got a response. Burp then issued the same request, but with a shorter content length and got a timeout. This suggests that the front end system is using content length header and the back end is using transfer encoding. You should be able to manually verify the repeater, provided you uncheck. I did uncheck it, okay. Interesting. So it's using... That was it? Did we just solve this? Yeah, we did solve it. Okay. So the same exploit worked, and the trick, which Bert found for us, was that if we use the transfer encoding identity here, it probably tricks the... it tricks the back end, or the front end. It tricks the front end into using content length rather than wait, is it? Yes, it tricks the back end into using content length. And if we were to swap that ordering, it will not work. Because it's probably such the implementation is using a oops. Yeah, this will fail here. I guess the question is, can we like swap this with like anything? Does it actually have to be identity? Can it just be like blah? All right, so that worked. All right. Put this back into a good state, which is just doing that. Cool. Yeah, so that worked. It doesn't have to be identity. It can be literally anything. It's just that it's getting rid of the value here probably. Like I wish we could see the servers and see like what is happening here. Like it makes sense. Like I wonder if we could like if it's case sensitive. Like will this work? No, so that doesn't work. It would be giving us that if it worked. So that's cool. I mean, you basically just have to run through all the various like things you can do here, so different tricks, and it seems like that's like what this extension does when it does the probing. So how do you prevent it? HTTP request smuggling vulnerabilities arise in situations where front-end servers forward multiple requests to a back-end server over the same network connection, and the protocol used for back-end communications carries the risk of two servers disagreeing about the boundaries. Some generic ways to prevent HTTP request smuggling vulnerabilities arising are as follows. Disable the reuse of back-end connections so that each back-end request is sent over a separate network connection. That is true. No, the different casing doesn't matter. The casing doesn't matter here, I don't believe. So I think the reason this worked, and I can move this back to this, and this will so that request worked, and then if we go back to here and refresh this, we should get the same thing. Yeah, unrecognized method gpost. Doing it again, it'll get us back to a good state. I'm guessing that the reason why this works is that so the front end server is going to treat this as transfer encoding chunked. It's going to read the headers and it's going to see this is the first one coming in and it's going to basically ignore this. And so it's going to treat this request as, transfer chunked encoding. It's going to get forwarded to the next server, and the backend server is going to, what I'm assuming is see the content length here. It's going to see the transfer encoding chunked here, and then this transfer encoding is going to replace the blah is going to replace the chunked, and because this isn't valid, it's going to end up using the content length and treat it as a non-chunked request. Or it's just that this was the first one in, like this header came before the transfer encoding headers, and so it's going to treat it as non-chunked. I mean, we can test that theory by moving these above the content length, and basically it would get rid of this. So that worked, and then yeah, so that doesn't work. So that's why I think it has to do with I think it has to do with the differences between first in wins or last in wins, which is what you typically like refer to like caches, like those kind of scenarios. Like these probably get stored in a map somewhere in the server, and these are the keys, these are the values, and like, if the key's already set in one, it won't bother setting it again because it's using the first one, and in other cases, like it will just, whatever is the last one in will end up like being the one that gets chosen. So yeah, this should work, but probably in like a performance like environment. I don't know like what this would do to performance. It probably wouldn't be good. I'm kind of curious like how much HTTP2 is being used right now. I know that HTTP3 is getting released, and it's I think like it switches out the protocol for Quick, which is like a newer protocol that I think gets them away from I think it's TCP, but I can't remember. I think they're basically built like TCP over UDP. I can think here. Use TCP for transport. HTTP3 uses Quick, a transport layer network protocol developed by Google. Use over UDP. The switch to Quick aims to fix major problems called head-of-line blocking because of the parallel nature of HTTP multiplexing is not visible to TCP's loss recovery mechanisms. A lost or reordered packet costs all active transactions. Inexperience is still stall regardless. So I'm assuming that means that because packets need to be acknowledged on the back and forth, if you have a packet get lost, everything else in the pipeline waits until that comes back, and this allows like out of order reception of packets. So if a failed packet comes, it won't block everything. So this is like generally available. I think that Quick has been available in Chrome for like a while. No, I haven't seen that. Using HTTP hop by hop request headers. Let's I don't have this. Let me. Yeah, I think they just got to the point where they decided that HTTP3 is like okay. I don't know if it's ratified yet, but I think it's like the general consensus is that like this is the path forward. I saw an article about this like maybe like a couple weeks ago. Um, but yeah, how does maybe it's not enabled by default. But, it looks like the browsers support it. They're just not enabled by default. I don't know what needs to happen from quick to yeah, seriously. Yeah, I don't know what has to happen for them to actually switch. But I mean, I imagine that like if you're like running like a load balancer, like you're using like an ELB in Amazon, like and you're reverse proxying, or you have like Nginx and like you're reverse proxying. Like if you have appliances, like especially appliances, like that shit's not gonna switch over to HTTP 3 anytime soon because you gotta wait for like Amazon to update their load balancers, and you gotta wait for I don't know who are the other ones that like do all that bullshit. Like you basically need to wait for your appliance to support it, or like the application server. Yeah, exactly. Some are still running like 1.0, or you need to wait for like the application server that is your backend server to actually support it. Like when is Thin or Unicorn, like in the Rails world, gonna get HTTP 3.0 support? Like even if your reverse proxy supports it, like if it can't talk, HTTP 3 to your application server, or like old versions of Jetty or WebSphere or whatever the fuck else you're using, like the backend server like needs to support it. Otherwise, it's not a viable strategy. And so like, I mean, it sounds like HTTP 2 solves this problem as well, and 3 will probably continue to fix it. But I mean, I don't know. Like, I don't know if WebSphere supports like HTTP 2 or not. I am curious about this though. I haven't seen this blog post yet. Wrap up the text. So I didn't know this, but I mean this makes sense that like as you have different levels of proxying, like they're gonna swap out some of these headers because the behavior you have at the edge is probably going to be somewhat different than the behavior you have behind the edge in terms of like your encoding. Like you might not be doing like gzip encoding or fancier encoding. I don't know if like 7-zip encoding is supported like by browsers, but like presumably like you could do gzip encoding of your data from like user agent to the edge, the load balancer, and then from load balancer to your application, or during those hops you could switch over to like 7-zip or something just to get better compression rates and transfer less data if that was something you cared about. And I assume that like all of these other headers here all have like similar like reasons for doing that. So it explains why you're seeing that different behavior around including 2 transfer encodings. Yeah, that might be the case. How long is this? Something we can like read real quick. Yeah. So a hop header is a header which is designed to be processed and consumed by the proxy currently handling the request, as opposed to an end-to-end header, which is designed to be present in the request all the way through to the end of the request. 2612, the HTTP 1.1 spec treats the following headers as hop by hop by default. Keep alive, transfer encoding, TE, which I don't know what that is. Maybe transfer encoding as well, but like shorthand. Connection, trailer, upgrade, proxy authorization, proxy authenticate. Using default custom set of headers to treat as hop by hop. In this example, we're asking the proxy to treat xfoo and xbar as. I did not know that was how that worked. That is very interesting. Meaning we want the proxy to remove them from the request before passing the request on. I wonder if you could use that to like get the proxy to remove. You probably wouldn't want to remove X forward 4 headers Like that, those are things you'd want to like add in. But I wonder if there's like other headers that have to do with stuff that like if you were, yeah, you totally could spoof it. But like I wonder if there's like attacks where like there's data being appended by the proxy that by just like the ordering in which it would do it, like using the connection header, you could get it to stop. Oh yeah, that's interesting. I didn't even think about that. But yeah, if it only tries to remove the first one or the last one, that'd be pretty cool. And like a cool way that you could get it to like if you have header injection, but there's already one being injected, like you could get it to potentially remove the one that the proxy's adding, and then use your injected one instead. Uh, so the act of removing a header from HTTP request is not necessarily going to cause issues. However, being able to remove headers that were not in the original request but were added by either the front end or another proxy in the chain could create unpredictable results. It's basically like turning off a switch. It could do nothing at all or be catastrophic. For example, perhaps a header is added somewhere in the chain which instructs the backend of an access control decision, or the fact that the request came in from an internet user, and its absence in the request triggers a logic change in the application. Perhaps application logic is assuming a header will be present because a proxy unconditionally adds the header and dumps out juicy debug information when it's not there. Is the act of a front-end proxy forwarding the hop header list can be create issues as any header it adds to the request may be up for removal by the next hop. Listed as a default hop by hop header, this would suggest a compliant proxy should not be forwarding a request list of custom hop by hop headers in the next server in the chain. Its connection header when it forwards a request that is a compliant proxy should. I wonder if someone's done like an assessment of like how compliant these proxies are, or like does Nginx respect this? Does Apache do it? Like what else is out there that does it? Oh yeah, totally. Like, I mean, these are the kind of bugs that just have been around forever because they're hard to catch. Like, you don't know it's there until someone like figures it out, and then it's there until everyone like either they patch it upstream and the behavior changes, or they patch it. You know, everyone just changes their configs to like change the behavior. Um, so yeah. This is cool. Cache poisoning, denial of service via hop by hop. That's really fucking cool. uh, what? WAF bypass. So I don't think this is the reasoning for why that's failing. Like it's partly like the front end header is going to end up like figuring out what to pass for for this. Like it's going to either choose to do a content length or a transfer encoding. So it's related, but I still think the reasoning like why this works is that it's it having two of these ends up replacing the chunked, and so it doesn't actually think it's chunked anymore. But this is really cool. I didn't know about this, and like I definitely need to start incorporating this into into my testing. Like there's probably tons of places where like you can do these types of things and it like things just break and you don't know. And it's one of those things that like as like an engineer, like you're not gonna know this. Like you're building your application, but like you don't necessarily know how the how everything is gonna be like set up when you deploy. Like you don't know what your environment's gonna be like with your reverse proxying and everything. What was the last one here? So you use exactly the same web server software for front end and back end, so they agree about the boundaries. Yeah, so this is probably like pretty important, but I think that like this is like might give you a false sense of safety. Like the problem here is that like it's not just the same software, but like the same versions. I mean, like you might have like a difference in Nginx from one version to another. Like I said, like they might fix one of those bugs where like the behavior changes, and if you have two different versions, like one is going to think one way and then one other is going to think the other way. And for the most part, like this isn't really possible because a lot of the time what you have at your backend server is not necessarily going to be a reverse proxying system. It's going to be your application server. It's going to be your Jetty, your Tomcat, your Thin, Unicorn. Like I don't know what's common now in like the Rails or Python worlds. It's going to be like your Go application that's running there. Yeah, totally. Let me refresh this. I think that one's solved now. I think we did all of them on this. What else is in here? Like, also, what's in the learning materials? I didn't know any of this existed, and this is really fucking awesome. There's a whole bunch of DOM-based stuff, which I personally think DOM-based stuff's kind of boring. It makes a good demo, but I think it's kind of hard to actually like pull off in a meaningful way. Oh, cool. So they do have a deserialization one. I wonder if it uses the YSO serial integration or if it's done by hand or something. So what are the labs? This is like XSS, CSRF, cores. Yeah, exactly. With Nginx in front or Varnish front, not tie deployment details to application software. Yeah, I mean like, and all of a sudden like your edge technology might change and you decide, oh yeah, we're gonna switch from Nginx to something else because it's more performant, or someone releases like a new reverse proxying system, or you end up rewriting your application and so or redeploying your application server or your web stack that the application server is running on, and all of a sudden like it changes out from under you. So like I don't know. I mean, I've worked at a lot of small shops and not a lot of big shops, but even in the small shops, like most of the engineers who were like building stuff like didn't really know how a lot of the deployment stuff worked. Like there were a handful of us that did, but like I think for the most part, you know, they focused on their little area and like that's all that they really like looked at. So I think the one thing that kind of sucks about this is you need to have a an account on here, but I don't know if you need to have a valid burp license to get to this content. I haven't tried it with like a non-valid burp license, but you definitely need to be logged in order to like track your progress. And I don't know if you can do the labs without being logged in. It looks like it basically spins up like a Docker container for you, and and uh, and just gives you like a fresh instance that doesn't collide with anyone else. But yeah, I definitely want to spend some more time on this. I think, like I said, a lot of the stuff here I'm already very familiar with. Like web has been my bread and butter for a long time, but like I definitely do want to get better at using burp in general, which is something I said yesterday. And so I think this will be a good like opportunity to kind of like just play with burp and get better at using it to like do these things. Because I'm sure like all these labs are basically built around using burp as like the, you don't have to, but it's designed around like showing off burp so that you go buy it. Oh, cool. So yeah, if you don't need to be logged in, like yeah, I don't know like how good any of this stuff is. Like I've seen just a small amount of it, but like when you compare like what's here with what's in uh like the web course that like OffSec offers, like a lot of the content seems to be pretty equivalent in terms of like the topics covered. So like where's the syllabus here? Here it is. Um, Tons of a little bit of burp stuff. And like the thing that I don't really like about OffSec, and like you know their certs or whatever, but like the thing that like I don't like about OffSec is that so much of the labs are based around like this specific application that has the vulnerability in like this place, and so you're learning less about exploiting the vulnerability and more about like using this exploit and going and using it. But like I don't know, you're not bug hunting as much. Like I mean on my OSCP, like I basically spent most of the time just kind of looking for existing exploits, and like it seems like a lot of that is the same here. It's like they have these case studies where it's like you have some application and you go and you run through it, but it's not teaching you how to like necessarily like bug hunt it. It's pointing out like this is where the bug is. Here's how you exploit it, which I think is nicer about I don't know like these kind of labs. Like the one thing I do wish, yeah, 100%. Like I like it's very much tailored toward like black box like testing, which like is good, but it's only going to take you so far, especially when you get into environments that have a lot more mature security programs where you don't have a lot of like low hanging fruit that's just like available anymore, and you do need to start like actually bug hunting and actually like finding new stuff. But like the one thing I wish you got here was like if you could get some like ability to actually like talk with the server and see like what it was seeing, so it could help you debug it a little bit. Like going in like blind on this kind of sucks. Like I mean I understand it, like it's how you're gonna do it a lot of the time for like a real environment, but being able to like learn the material while having a debugger that you can be like, this is how you do it and this is what you like this is what you're seeing, so you can figure out like from what I'm sending, this is what it looks like. I personally think it makes it like a lot easier. Request bin type service. What's request bin? Oh, I've never seen this before. This is cool. Yeah, exactly. Like it's like something like this where you could like you can see like that intermediary point. Like I want to see like what the front end server sees, and then I want to see the like the request that the back end server sees, so I can see like how it's mangling it and how it's getting changed. It makes it so much easier to conceptualize like what's happening and like what you need to change in your exploit to get to the point where like it's actually going to do what you want it to do. And like, yeah, I mean, doing this blind, like you're gonna eventually get it, and you'll make, it's how you're gonna do it in real life. But just like, I just feel like it's faster. Like you can move to the point where like I'm doing this thing, I have instant feedback. I'm not guessing. So let's see here. There's like 2 more pages here. I can go back. If I can find... Oh, no, this isn't it. I go back further. Yep, here. Okay. Finding an... So we're not on exploiting. We're on... I guess this is like an overview, and then this tells you how to find them in applications, and this tells you like how to use like meaningful exploits for them, maybe. Like this is cool that they're actually like teaching you like this is how you would find it in an application, or this is how you would do it. I don't know how much of this is just like, run this thing in burp and then it will like spit out the answer. Like burp did help, like the scanner did help us, but like I don't know how to use the tool at this point to actually like do the exploitation. Like I can write it by hand in repeater, but like I don't know how to use I didn't see exactly how to like get this to do it in the like in here, like the smuggle attack. I wonder if it's worth like reaching out to Portswigger and seeing if like that's something that they could provide. Like, I don't know how incentivized they are for it, but like they seem like a good company. Like they seem like they care. So let's see here. We'll explain the different techniques for finding HTTP request smuggling vulnerabilities. So I wonder if this goes to the manual steps that like the plugin is doing in Burp. Because the plugin tells you a little bit about like what it's doing. If you go to here, like the advisory, it tells you like it issued a request and got a response, and then issued the same request, but with a closing chunk. So the most generally effective way to detect HTTP request smuggling vulnerabilities is to send requests that will cause a time delay in the application's response if a vulnerability is present. This technique is used by Burp Scanner, which we just talked about, to automate the detection of request smuggling vulnerabilities. If an application is vulnerable to the CLTE variant of request smuggling, then sending a request like the following will often cause a time delay. I wonder if this causes a time delay because, so let's see here, it'd be 1, 2, 3, 4. This isn't enough for like a full request, but there's one here. Since the front end uses the content length header, it will forward only part of the request omitting the X. The backend server uses transfer encoding header. Process the first chunk, and then it waits for the next chunk to arrive. This will cause an observable time delay while it times out. What's the curl bash trick that relies on the time delay? Is that like you mean like curling into bash to like install stuff, or like is there like something else? And then the TECL version. If an application is vulnerable to TECL variant request smuggling, then sending a request like the following will often cause a time delay. So you're giving it a 0 chunk, but the length is 6. So 1, 2, 3, 4, 5, 6. Since the front-end server is using transfer encoding, it it will forward only part of the request, emitting the X. Backend server uses content length header, expects more content in the message body. So it only got 1, but it was expecting 6, so it's waiting. Since the front end uses transfer, okay. Let's see. Didn't have anyone trusting enough to type content directly from the internet into their bash shell, or alternatively figures out how to bypass the pipe check in the server. Details about this attack can be found here. Let's enhance. So the key difference is the time it takes for the contents of large HTTP responses to be ingested by bash. Execution in bash is performed line by line, so the speed the bash can ingest data is limited by the speed of execution of the script. Oh, so you're looking at how long it takes to read, because it's going to read it byte by byte or some amount. If we return a sleep at the start of our script, the TCP send stream will pause while we wait for the sleep to execute. This pause can be detected and used to render different content streams. Unfortunately, it's not as simple. A case of wrapping socket send sleep 10 in a timer, waiting for a send call, filling. To detect the pause in execution, we need to fill all buffers before we pipe to bash. The flow of data from HTTP response looks like this. Both the send and receive buffer sizes on Linux are auto-tuned per socket. So you have to do this in your server. Chrome, on charts so that's bizarre. So you're sending up a bunch of nulls after that just to fill it up. So how do you guess? If you chart the time between each chunk is sent, and do this for both scenarios, it becomes easy to determine which output to pipe to bash. What does the server look like? So this is the padding. Okay, and so it's hard coded here. That's pretty cool. Didn't know that was even a thing. That's awesome. Probable request smuggling vulnerabilities is detected. You can further obtain evidence for the vulnerability by exploiting it to trigger differences in context of the application's responses. This involves sending two requests to the application in quick succession, an attack request that does not interfere with processing the next request, and a normal request. If the response to the normal request contains the expected interface, the vulnerability is confirmed. For example, suppose the normal request looks like this. The request normally receives. Yeah, definitely. Like I said, I haven't really played too much with it, but like there's so much stuff here, and I don't know. It's one of those things where it's kind of abstract. It's how I feel like about like heap exploitation. Like so much of that is very abstract. Where like you look at like stack exploitation, and like writing like stack based memory corruption. Like it's really simple. Like there's like you're overwriting like one thing, and like pretty much in every variation of it you're doing like more or less like the same kind of thing. Whereas like and it's a very like we're just gonna go straight from this point to this point and we just get it. And with this like it's very nuanced, and like there's techniques, and like you have to figure out like what kind of environment you're in, and like which techniques will work in this environment, and like how you kind of like coerce the environment to do like what you want it to do, even though it's not like set up to do that. This is cool that like you can do you can turn like this line into basically a header and then grab it. So like one like you could use this to like basically steal someone's cookies, but like you get this next partial request going, and you set up like a request to somewhere, and like the user who's making that request, they've got valid cookies, so in a valid session, they've got a valid CSRF token, and so you're basically, it's not quite CSRF, but like you're getting them to like go to the request that you want, with like their credentials and like all the bypasses for it, which like is pretty sweet that like you can do that. I don't know. I feel like reading this on stream probably isn't like the most interesting or entertaining kind of thing. My voice is also starting to go. My throat's killing me. I might end it here and just wrap it up for the day. It's a good like a little over 2 hours. We got through the first set of these. Maybe we'll do some more like later this week. But yeah, this is pretty cool, and like I'm happy to see like all this content here. I definitely want to go back and do it. I might just churn through some of these labs on stream at other times, and we can just like do them. I don't know that I would need to go through like the learning materials for some of it, but like it seems like it might be interesting. Yeah, you too. Hope you're doing well. Talk to you later.